Welcome back to the channel, everyone. This is Code Meets World, continuing the NeetCode 150 series where I'm solving all 150 NeetCode problems without preparing for them at all. So, I'm through 8 of the 150. Last video, which I'll link here, I did the reversing a linked list problem. Go check that one out if you want to have a good laugh, because I over-engineered the solution completely, and I think there's a much simpler way to do it that I didn't think of. And so I might record another video for reversing a linked list to have a go at the much better, much faster solution. But I finished it, it worked, so I'm counting it as done, and today I'll move on to the merge two sorted lists problem. Hopefully I have a bit better luck with seeing the right solution to this one. So we're still in the linked lists category. And the instructions here are as follows. You are given the heads of two sorted linked lists, list 1 and list 2. We need to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So we have an example here where these are the two lists in red and blue. And then we want to sort them. We want the final linked list to remain sorted, basically. So we would take the 1s first, then we would want the 2, the 3, and then the 4s. So it looks like if they're empty, we just didn't do anything. 1's empty. Take the other one. The number of nodes are between 0 and 50 in each list. The nodes can have negative values. They're sorted in non-decreasing order. Okay, great. So let's pop over to whiteboard and have a think about this. So this is reminding me of some sorting algorithms that I remember. And in particular, I think there's one part of a search or a sort algorithm that I remember that might help us here. So let's say we have, let's draw it like they have here. So we have 1, 2, 4. And we have 1, 3, 4. So, and then let me make the final list blue. So something that I remember is because these are both sorted already, and that's a huge bonus for us, we can just start by looking at the front of each of these lists because we know they're sorted, and just pick whatever one is smaller. So in this case, because they are the same, we can pick either of them. So we'll take, say, the red one from the top. And again, I'm writing it in blue, but we just took this one. So now we have a 1. So that after that, we would compare this one with this one. So once we add a node from one of the two lists, we move to the next one. So now we're considering between these two, and of course, 1 is smaller. So we'll add the 1. Now we're not considering that one anymore. Now we're looking at these two. So then we want to add the 2. So we're done with that one, and we move on to this. Then we want to add the 3. Now we're considering these two, which are 2 4s. So we would add those. And then everything has been considered. So I think with this one, it's fairly straightforward. We just compare the front of each list, and as we add something, we move on to the next one. And in the case where either list is empty, so for example, case 3 here, if either list is empty at the start, we can just return the other list, because if this one is empty, we won't ever be adding anything from it. So list 2 could be as long as it wants, and because we know it's sorted already, we would just return that list straight away. And that little trick works for this case too. We would see, oh, this one's empty, so just return the other one, which is empty, and that works. Great. So I think that's what we want to do. So let's see if I can write the code to make it happen. Okay, where to begin? So we're given list 1 and list 2, which are, I think it said, the heads of 2 sorted linked lists. Okay, so let's make a variable called a new head and set that equal to list node like this. So this will be my new head. And what I'll do is I'll immediately point that to whatever the smallest of the 2 lists that I'm given is. So okay, that's my new head, and that's what I'm going to end up returning at the end, I think. That should hopefully make sense. Okay, and then now what do we want to do? We need to basically create a runner or something for each list. So we'll say list1 underscore temp equals list1 and list2 temp equals list2. These are basically just going to be nodes that I can use to go down the length of the linked list and check what values I'm seeing and move to the next one once I add it to the list like I showed in my picture. So then I think we need a while loop here. So we could say, or we could actually just check something right off the bat, which is if list1 temp dot next so actually we can say if list1 is none, we can return list2, and same thing if list2 temp is none, we can return list1, and that'll handle that handles both this case and that case. So then after we do both of that, I think now we can do the while loop. So while list1 temp while not and instead of saying is, I'm just going to change these to equals equals. I think it makes more sense that way. So while list1 temp does not equal none and list2 temp does not equal none, I need to compare both of them. Maybe I can just say, I'll come back and think about, I'm not sure if that conditional is, I don't know if I like that. I don't think that's exactly what I need, but we'll come back to it. So basically this first part is check which value is smaller. So what we need to say is if list1 temp dot val is less than, or we could also say are equal to, because in the case where they equal, it doesn't really matter which one we take. List 2 temp dot val. So in the case where list 1 is less than or equal to the value in list 2, we need to take the value from list 1. So what we can do there is say I need another variable here, I think. One to keep track of the start of it, and then one to keep track of it as we go along. So we can say new temp equals, what I want to be able to say, for instance, is new temp dot next equals list 1, no, equals list node list 1 temp dot val and none. But once I do that, I would want to say list 1 temp. So once I use the value in one of the lists, like I was showing in my drawing, I crossed it off in the drawing once I've used it. In this case, I want to move my pointer to the next value. So I could say list 1 temp equals list 1 temp dot next, like that. And then I would have to say new temp equals new temp dot next. So we're building the list as we go. In the other case, we need to take the value from list 2. So we would say list 2.temp. List 2.temp is list 2 temp next. And then we change new temp. So I think that'll work. I think I'm actually going to change this to while true and then do a few checks. One such check is if list 1 temp is none. In that case, we want to say, because in the case one, basically if either of the lists, if we end up getting to a place where either of the lists are none, we know we need to just append the rest of whatever the other list is to the list that we're building. So in that case, what we can do is say new temp dot next equals list 2 temp, which should append the rest of list 2 to our final list that we want to return. And so similarly, if we see that list 2 temp is none, we want to do the same thing, but for the other list, we would say new temp dot next equals list 1 dot or underscore temp. Sorry for the variable names here. I don't love the way I've called these variables. And of course, in either of these cases, we would then want to return and be done. I think I need to return the head. So return new head. I think that's what I want. I need to make sure that I set new head properly. Okay, so if either of them are none, we just append the rest of it and we're done. So it's almost as if I need to do basically check which one I need to start with at the beginning. So if that's the case, then we need to say new head equals list 1, otherwise new head equals list 2, and then I can take away new head, set this here. Perhaps this will work. Let's give it a go, shall we? Time limit exceeded. Nice. All right, so something's not working. Let's test it on. Let's test it on. Well, first, actually, for the test cases, let's quickly get rid of those and try it on these two. Make sure that works for both of those, because it should handle both of those right away. Yeah, and it works for those. Okay, so just these two that it has wrong. So let's see. So it checks if either or none, they are not, so that doesn't happen. If list1.temp.val is less than list2.temp.val, new head is set to list 1. So we would be pointing new head at this 1 here. And then we'd set a temp equal to that, so we have that as well. Right. So new head equals list node. Let's try this instead. Where the value is this. And the next is none. And likewise, new temp is new head, right? So I'm just going to be creating new nodes every time instead. So we create a new head. It has a 1. New temp is equal to that. Then we loop. And basically, list 1, neither of those are none, so those aren't going to happen. Oh, okay. Also, because I basically did the first one, I have to now say, in this case, list1 temp equals list1 temp dot next. Same for here, but it's list2. In those cases, and again, yeah, these don't happen. I've moved the temp node ahead 1. Then I check which one is smaller. In this case, it would be the next one. So it would fall down to this one. The new temp is equal to new head, which I've set. So we would say new head dot next, or new temp dot next is another list node. We take the temp val, we set the next one to none, and then we move everything. Okay, this might be better. Yeah, okay, wonderful. Let's submit that and see if that works. Okay, nice. So, sorry for the long solution there, everyone. It took a little bit. It was really easy to conceptualize, but then it took me a little bit to think through the code. Hopefully that all made sense. Here's the solution again. But it looks like my runtime is excellent in this case. I'm really happy with that. That might be the best I've gotten. About 99 percentile runtime, so that's cool. And then didn't do super well with memory. I think that's because I created a new list from scratch. Completely recreated it with new nodes, and I probably could have done something clever where I just changed the connections around. It seems that linked lists are not my forte, so when the day comes that I need to study all of this, linked list is the first part where I'm thinking I'm going to need to spend some time, because I'm struggling a little bit with how to do these connections, but I was able to get it. So we'll check that one off as done. Thanks so much for watching, and I will see you next time.